Hi, I'm Danny. I'm happy to be here. I love this conference. I've come here as a guest. It's the first time I'm speaking. And the reason I like this conference is because of the in-depth tech talk. We have 40 minutes. We have more than 100 slides to go, so I will speak very, very fast. So if you're on a recording, just make it slower. Sorry for the ones here. Let's talk about Junit5. I found this slide some time ago. This is me talking. It's a slide deck from me 10 years ago. It's a conference in Santa Clara, BlackBerry developer conference. BlackBerry is where these things with a keyboard before Android. I was talking about JUnit by then. It was like something called J2ME unit actually by then. So somehow I ended up keep talking about testing and JUnit for quite some time now. Just keep an eye on this. This is the startup I'm working on. There is something cool coming up soon. And we are looking for front-end and back-end in Berlin, especially if you see the recording. Apply, please. Let's talk about JUnit. To understand why we have Junit5, we have to go a bit back. So come with me on this little time travel. And we go back to the year 1994. Anyone did professional programming by then? I was, oh, wow, one. I was in school. So I give you a little perspective about the time. So that thing arrived as a zip disk. Maybe someone remembers that. You could put a lot of games on it. That's what I remembered back then. It was also the year a guy called Kent Beck wrote SUnit. S stands for Smalltalk. He basically had played around with a lot of different testing frameworks, didn't really like them, and then he was on the way to a client and played around with the workspaces he had and ended up with 3 little classes: test case, test suite, test result. It was like 12 method, and he hardly called this a framework. He thought it doesn't have much value. But it got a little bit of traction. Like Martin Fowler said, everybody did something similar, but he liked the simplicity of this, so he stitched his own. But it kept a bit low. So let's go 3 years into the future from there, 1997. Again, a little bit of perspective here. This rewritable CD arrived. This is the year we're talking about. You could put even more computer games on those. This was the year that, again, Kent Beck and his friend Eric Gamma, they were on a flight from over the Atlantic, from Zurich to Conference Atlanta, an object-oriented conference. And I mean, they had some time to kill, right? And what do 2 nerds do when they're on a flight and have to kill time? Of course, they do some test-driven development. So basically what they did is they wrote a Java version of SUnit. Seriously, they did it completely test-driven, a testing framework, test-driven, giving each other a high five. That's what Kent Beck tells in a video. Yeah, and they ended up with JUnit. So this was how JUnit was born, on a flight. And the thing that we don't recognize is how much the world changed because of this. Think about the testing framework you used. UI Automator, Espresso, I mean, all of these based on JUnit. Even other platforms, they have all based off what we now call XUnit. That's what Martin Fowler called them. So let's quote Martin Fowler. He said that never in the field of software development was so much owned by so many to so few lines of code. JUnit really changed the world with testing. Why? The key thing here is, and it's important to understand when we talk about Junit5, was the simplicity. This, for the first time, enabled developers to actually write tests. Testing wasn't for testers anymore. Developers should write this. And one of the reasons, I think, was because of the way they did it. So there was a little test, a little code here, right? I mean, the whole thing did a TDD. This is why it makes it so simple. It's not something that you do afterwards, like for weeks, right, after you wrote a program. And it was very flexible, so everybody could modify it. Actually, so it was Kent Beck and Eric Gamma writing this, but other contributors came in after they heard about this JUnit thing. For example, if you ever wondered who's responsible for the ugly assert equals method in JUnit, where like the message is the first argument and then they expected an actual, it was Martin Fowler. And so even the big guys did mistakes, and he admitted by now. One thing that wasn't there before was test isolation. And that was something that was really important for Kent Beck. Because from a QA testing perspective, you test one thing, and this leads to the next one. But developer needed this isolation, right? Every test stands on its own. And JUnit had that built in. So JUnit was a big success, and we will jump nearly 10 years into the future. 2006, 12 years ago. To give you perspective, WikiLeaks started. Small website by then. And JUnit4 was published. It was still back in Gamma behind it, behind the project. And it was a little bit a big cleanup. There were some things that Kent Beck didn't like in the first JUnit, but he didn't know how to make it better. For example, you had to extend this class called testCase. By now, Java 5 was there, you had annotation support, so they could clean up a little bit. So the inheritance was gone. Test names before, they didn't have a test annotation, so they needed to start with the word test. And funnily, until now, developers still start their methods name with the name test. You don't need to do that. And look at the Google I/O update. In the test there, people still use this, which is really funny. Because 12 years ago, we could have stopped doing this. Also, runners came in JUnit4, so very crucial concept. It wasn't there before, which is very interesting. So JUnit4 changed for a long time the way we tested. Let's jump to 2016, just 2 years ago. So you don't need perspective on this, but something happened there. On the crowdfunding platform Indiegogo, a project appeared called JUnit Lambda. And this guy here, Kent Beck, he grew a little older. He wasn't the originator of this project, but he asked to fund this project, to keep JUnit young. Because the idea is that a few developers wanted to fix some things and brought JUnit to the next level, and they needed someone who could do this full time for some time. So they needed some money. And they reached their goals, like $60,000, roughly. 200% of the actual goal that they made, by nearly 500 backers. So developers were interested in this. Let's look into what was the goal of JUnit Lambda. The runners problem. We just heard as runners were introduced in 2006 in JUnit4. And since then, they became a very crucial concept of JUnit. But they had a problem. There can only be one runner per test class. And we all, probably most of us, ran into this. What did we do? We moved stuff from runners into rules. This was possible because there was this overlap in functionality. But the problem is, because of the problem in runners, we misused rules and everything got messed up. So they wanted to fix that. But there was more. The execution model didn't fit into the modern time anymore. In JUnit, until then, the tests need to be known at the moment you want to run them. But there was no Java 8, there were streams. A lot of people wanted to use parameterized tests. There were third-party tools for this. So it was more like, can we dynamically create tests? Can we have data-driven tests? So they wanted to change this. Another thing that they realized, and this was, I think, the most crucial problem that JUnit has right now, the tools integration. JUnit is everywhere, in Gradle, in Eclipse, in IntelliJ, right? We have it all over the place. That is good, but it is a problem. Because do you know the SDK, the API that they're using? There is no. JUnit was meant for developers to write tests. There was no integration for tools. So in this crowdfunding campaign in the video, they showed the example. They took the assertion class and renamed 2 private fields in there. They had some prefix. It's an old code base. They just want to remove the prefix. And the IntelliJ broke. Everything was so tied up. There was reflection everywhere. So JUnit was basically unmaintainable. You can't touch a single thing without breaking an integration. So the vision that those guys had were, let's decouple the execution, the reporting, from the actual definition of tests. Let's rethink the runners and rules. And let's make Java 8 features and dynamic features available. That meant rewrite it all. It was called JUnit5 and it was released the same year. It is stable since last year. Current version is 5.2. And let's look into it, because that's what this talk is about. So look at this test. Is this a JUnit4 or the JUnit5 test? You probably don't see it, right? The only way you could see it is looking at the import, because everything that you use in JUnit moved to a new package in Jupyter API. And because they did this, they could adjust some things that wasn't really clear in the beginning. So some of the annotations were renamed. For example, you could see that before and after, those annotations were there before, and then someone thought, oh, maybe we need some on class level, and they added before class. So before each and before all are now the new ones, much more clearer. Also, add ignore is a bit confusing. What you actually want to do is disable a test temporarily. And I said they want to rethink rules and runners, right? Those annotations are gone. I will explain later what is down there, but there is no add rule, there is no run with anymore. What is really nice since version 5.1, there's actually a Kotlin module sitting in Junit5. So you have extension functions for Kotlin, which is pretty cool. It also shows how responsive those developers are on Junit5. So they're really asking for feedback, they're really responsive. And they added Kotlin support, which is pretty cool. So in the project that I was working on, it was a greenfield project, we started in January, immediately went to Junit5, and the first thing I noticed was this. This is the test output of Junit5. And you might think, what's the thing here, right? I mean, I probably have some fancy shell. No, I have the most basic shell you can imagine. This is how it looks like, with all these nice colors. But you might say, hey, I have like a nice output anyway, because I wrote some script for it. The problem I always had is I was logging into my CI system, Circle CI or whatever, and I would see this long output and trying to figure out where's the actual issue. And now it looks really nice. It's very easy to see. So it's not really a feature, but the first thing I noticed, and I love this. Let's look at actual features. A new annotation at display name was introduced. So basically, you can give your test method an alternative name. And this one we will see in a test report. So you can give it like a nice sentence with space and everything. The only thing that I noticed when I saw this, hey, I have Kotlin. And my tests using spaces anyway use like the backticks, and these are my methods names. So I don't really need a display name. But those of you who use this know that this will not work on index format. So if you write espresso tests or something for the Android that runs on Android, this will not work. So a display name might be something you want to use. There's actually, according to Jake, an issue open to change this index format. If you know someone from Google, push that we finally get this in queue. Let's talk about assertions. The JUnit assertions most of us don't use directly, right? We use like hemquest and all of these others. I use the fast assertions a lot. In Kotlin, I use Fluent, which is a really nice assertion framework. But still, let's talk about assertions and what changed. Of course, a new package. We support lambdas now. One thing that I find interesting are the multi-assertions. Let's look at an example. So there's a new assert all keyword, which takes a couple of lambdas in the end. So what you can see there is actually 3 Fluent assertions. So you're like mixing 2 assertions frameworks here. And what assert all will do, it will execute all of them, even if the first one will fail, and then give me one result. So say, hey, title, description, and URL should be this, but it's actually this. So sometimes it's actually useful if you want to check multiple things, you don't want to run from one error to the next one. So costs a little bit of performance, but it might be really useful. Let's talk about this one. That's an assertion, kind of an assertion, that I never liked. Why? I write my tests, and most of us do, in like given, when, then. Arrange, act, assert. But as soon as the test that you're testing throws an exception, you had to reverse everything, right? Add throw sits on a method level. It never really fit in there. Good news, that thing is completely gone. We have a new assert throws now that takes an exception and a lambda, and yeah, the way you use assertion normally. But again, I'm already on Kotlin. I already have this. Kotlin has this built in, it's called assert fails with. In the end, in your team, just agree on one thing. There's an even nicer thing in Fluent if you use this, so our team agrees on this. But it's still nice that throws is gone. Another cleanup. Let's go from assertions to assumptions, which is a new thing. An assumption is something, if it's not true, it will stop executing this test, and it goes automatically into the disabled state. So you can use this for external conditions. So you have less weird if-else things in your test. Might be useful. In a similar direction goes tags, and that's something that we kind of had already to other ways. Think about the at-large test, for example, that Espresso brings. So you can define tags on your methods and on your classes, and then filter them from command line or from Gradle. So for example, exclude those slow tests. And actually, we use this test. I have some tests that call real API calls. So I mark them as slow, and I don't run them when I run my unit test. And actually, just a tip how we use it. I defined a new annotation called API test for those, because that's what they are, and added the add test and the add tag there, and use it now as an annotation. In a similar direction goes conditional tests. So there are a few annotations that you can use, for example, to disable something on your CI by checking the OS system or by enabling them on certain OS. Conditional tests are actually more like an API. These are just examples. So disabled, for example, is a conditional test and a conditional annotation where the condition is always false. So you can write your own based on this. But let's look at something that I find really, really useful, which is my favorite feature, nested tests. To be honest, I was never a fan of spec or Spock or any of those. And I always thought it's because I don't need nested tests. Now that I'm using it, and I'm starting, loved it from the first day, I realize it's probably more because of the way those frameworks had to use JUnit, because they were still based on JUnit, and there were these weird lambdas, and it didn't feel like a clean test I wanted to write. And the way JUnit does it now is really, really nice. So let's look into it. So basically when you open a branch for like a nesting, it's just an inner class that had an add nested annotation. And it's Kotlin with backtick. I give it a nice name when moving to player. And then you just add a test method there. Basically just an indentation. So just looking back, when moving to player, pass current clip. That's what we see here. And of course, you can nest it. And why is this nice? Because tests are specification. And with this nesting, you can write really nice specification of what you actually want to do. So I loved this on the first day, and then later another developer joined. And when he realized this feature, he suddenly started writing tests in like, he was really excited to write tests. Because all this thing that Jan said, okay, I need to test this and this and this, he would write it down in like this nested way. Oh, when this condition, then test this. And this is really, really nice. So look at the nested tests. Really, really powerful. Let's look, there's more things in Junit5, and they are meant, or they are set as experimental. But they are there since 5.0. But it just means they're looking for feedback. Repeated test. So maybe you want to call something 2 or 3 times just to make sure that it always returns the same thing. There's a notation for that, repeated test. Might be useful. And you can even check the actual repetition that you currently are, and then it generates basically, it looks like you have 3 new test methods in there now, which might be useful. One thing that definitely a lot of developers were looking for were the parameterized test. So I never had to use, but I know that a lot of developers are using already third-party frameworks for that. So the idea is you have an input argument in your test, and you pass, for example, here a string list. There are multiple annotations for the source. You can have a CSV, basically a list of whatever, can be multiple types, integer strings, whatever. Or if it's very complex, define method source, and then it's kind of like a factory method that you provide. To be honest, it feels a bit limited, just my tip, but look into it if it's your need. And as it's experimental, you can still give feedback. Dynamic tests are basically the next version of that. It's about generating tests on the fly. Tests that are not there when you write the test. Ideas also for very data-driven tests, where you have data from somewhere and then you want to start your tests. I didn't have this need, but I wanted to try this, and I saw one thing where we had a test that I didn't really like. There's a lot of nesting, and we realized that the innermost blocks are always the same. It was like, in this condition, don't send a message, and in this condition, don't send a message. And we thought about, okay, we can maybe extract a class for this, but it kind of hides the test itself. So I tried dynamic tests with that. And this is how it looks like. I removed those inner code blocks and just added this add test factory instead, which basically defines a function. And actually definition, I put somewhere else. And in the end, you see like a container, so there's a nested here of 2 tests. And I would, for example, when pending message is set to empty, that's the whole thing, and then don't send a message. And I would set it to empty, it's hard to see maybe, but it's like 3 lines per test, and in the end this will just execute as the tests would be there. One problem I see here, it is hard to debug them, because there's no line that you jump in, right? But with this pull request had like added those 20 lines and removed 400, so this was really rough for us. So now we will ask, okay, that's all fine, but I have Junit4 tests and I have thousands of them. And you said it's all rewrite. What do you do? Don't panic. Here comes Vintage Engine for you. So you have to understand how Junit5 works. It's basically 3 parts. It's a platform itself. It's a thing called Jupyter, which is the actual Junit5 I just showed you. And there's the Vintage Engine that is meant for Junit4 and actually even Junit3 tests that you run. And this will make more sense when I regroup this a bit. So you write either Junit5 tests against the Jupyter API, or you use your plain old Junit4, and this is not a new API, nothing was rewritten there. You use the same artifact, whatever version of Junit was, and program against this. All they added was this Vintage Engine that is able to run those tests. The nice thing is you can add your own engine and your own API. You can go crazy and build your own thing. In the end, they will all run by the platform. And there is where the tools manufacturer come in and program against this. So that's exactly what they wanted to do, right? Separate the whole thing. The nice thing is, now you understand why they have a new package. You can have those tests next to each other because they're completely separate test packages, and there's not a single conflict there. You will only see this when you run the test because two different engines run the tests. So for example, Vintage would run, there's no test here, and then Jupyter engine would run. So now the question probably you want to ask, so what about rules and runners? Like maybe your favorite feature or the most used feature. As I said, they're gone, which is not completely true. We have a thing called migration support for rules. So if your test rule inherited one of those three, external resources, verifier, or expected exception, and you add this artifact to your dependencies, they will work. Those are still supported in Junit5. If you like architecture components, for example, I found this lately, instant task executor rule extends test watcher. This is not supported, but actually then I looked into it, and test watcher is used a lot, but test watcher actually mean I want to watch a test, I don't want to modify it. That's not what they wanted to do. They wanted to have actually external resources. And they should just replace the superclass, and it should work. So if you extend test watcher, double check if this is actually what you wanted to do. So this is how you would use a test rule in the old times. This is a rule called toothpick. So toothpick is a dependency injection framework I like. And toothpick rule is something they use in tests. They give it out of the box, which basically whenever you want to inject something, it will look for a mock first, which is a really nice way of testing. Let's look how they implement it. So they implemented the initial interface test rule, which to be honest is a really confusing API, because you have this statement, apply statement method, then you return a statement, and then you have an evaluate method. And if you ever written a test rule and forget to call base.evaluate, all your tests will be green all the time because nothing actually runs, which is really funny behavior. So this is how this thing was implemented. Let's look at extensions, because extensions are the new rules. This is the new kid in town. And extensions are a bit, well, more thought. So every extension relates to an event in the execution of your test. So they have different types. There are lifecycle callbacks. There are things about parameters, about the exceptions thrown, and about the actually test pre and post processing. So I rewrote that rule to an extension by just implementing two interface after each and before each, which you can tell are the same as the annotations. These are the two lifecycle points I needed, and then did the same thing. And instead of the run with, I would do add register extension, which is there since 5.1. In 5.0, you could only apply them on class level. And it's was working fine. But we're in an Android conference, so let's finally talk about Android, right? So Gradle has built-in support for Junit5 since Gradle 4.6. Before, you needed a plugin. That's not deprecated. But we are Android, everything is different there, then of course this plugin will not work for us, because we have the Android plugin and everything on top of that. But for quite some time, Marcel Schnelle wrote a plugin that just enabled Junit5 for Android. He updated lately to Gradle 4.6. So if you used it before, there was a bit of weird syntax for your dependencies. Now it's the default way. So it's really, really easy now. So if you have pure Junit JVM tests, they run, you can have Junit4, you can have Junit4. There's not a single issue in Android. It works. Now you want to probably ask, what about Robolectric? Let's move this a bit to the back and let's start instrumentation first, which is another way we use Junit and Android, right? Instrumentation and Espresso. The way I want to mention that now, because this plugin had actually support for instrumentation tests. It's experimental, but I dropped it into a new project that I was working on. That was a Jetpack project with Android X test, which he doesn't even mention on the site, and it was working. I could run my instrumentation tests. Bad news, it needs min SDK 26. Why is this? Because the whole thing is meant for Java 8. The way Marcel suggests is have a flavor and only run this on SDK 26. When we talk Espresso, it's a bit more complicated because Espresso heavily relies on test rules. And these test rules are unsupported, so we need extension version of those. Because you have this add activity test rule, right? And in the earlier days, we had instrumentation test case 2, which is not even there anymore when you look at the Jetpack, so they removed this. So we need an extension version. So it looks like this, right? So instrumentation works, experimental. Espresso does not work. But we are developers, right? So what I did, I looked into this activity test rule. I just did a 5-minute copy-paste implementation like I did with the toothpick rule, and it was actually working. I could run an espresso test. Because there is some code in there that sets up the instrumentation registry, there's some idle resources, but all they want to do is have an entry point. So it's working actually really well. I couldn't test it on my real project, like the production project, but this is not related to this plugin. So I will look into this, because I have problems running the SDK 26 with espresso tests. So I couldn't get it working before the conference, but as I have it on a POC project, I'm pretty convinced it will work. So this is what I changed. The activity test rule I changed to my activity test extension. And probably I should put it, as soon as I get it running, I can maybe publish it even somewhere. So I think it looks more like this. So it seems to work. Give it a try. But now let's talk robo-electric. And you know, we can make it short and you all can go home. And I say, doesn't work. It's not supported, it's not intended, and not planned. Talked to the Android testing team, and they basically said it's so much effort to move into Junit5, but I hope the community will do it. So what would it need? So everybody is still here, we can continue. Let's look at robo-electric. So robo-electric is based on the Junit4 TestRunner. It relies heavily on custom class loading. So if you want to load an Android class, it would basically replace it by all this shadow magic. Whatever I tell you here now will change, because if you watch the Google I/O presentation, as robo-electric is under heavily rework as 4.0, and what I want to do is put robo-electric and espresso on the same base, so that's much easier to move between the two. But let's look at the current implementation of robo-electric. So it is a really, really heavy test runner, so there's no way I could get this implemented for this talk. But I had a different test runner that was also heavily relying on custom class loading, which was before Mockito 2 had support for mocking finals. I wrote this test runner that would remove finals from classes I want to test. So I looked into this, and this was basically this implementation that I have there on the repo. And basically what it does is it extends the block JUnit4 class runner and would create a new class loader and then modify basically this class and then pass it to super. If you want to know more about class loading, there's actually a talk later at 5 per sec about class loading. But this is how it works right now. So I wanted to build this as an extension. So I looked at the API. And the earliest point I could find is a thing called a test instance post-processor. This is the extension point. That gives you already a test instance, which I thought that doesn't look good. But let's give it a try. So as I couldn't use, load the class again, because this method doesn't return anything. So I thought, okay, let's just change the global context class loader and use mine. Maybe it works. And of course it cannot work, because the class already loaded, the instance is there, so I can't modify anything there anymore. So set Panda, set Keanu Reeves. But I looked more into the whole thing. So first I thought, hey, this is actually a design flow, right? I think this method should return a test instance so that I'll be able to modify it. And it's actually discussed on Junit5, and they basically said, no, the problem would be that there can be multiple of those extensions. And what is the order of those, right? Everybody modifies them. No, we'll not support this. But Junit5.3, which is currently in development, has a new thing called Test Instance Factory, which sounds exactly what I need. So there wasn't a snapshot for that, so I just checked out master and built it and tested it, and it looks much better. So you implement this method, create test instance, which creates a test instance. So this code looks pretty much the same as my rule. Have my class loader, load the class, and actually have a new instance, because I'm not supposed to run a class, but an instance. I was really confident this will work, and then failed. Why? I got this weird error. Hey, this test with runner on class is not the same as test with runner on class. If you ever dealt with class loaders, you will notice for Java, or for the JVM, if you have the same class loaded by two class loaders, they're actually not the same thing. And JUnit explicitly checks for this. They just didn't have a nice error message. They changed this up after a complaint, which is not my intention, but at least there's a better error message now. So they don't allow a class loader to change the test on a class on a test. And they said, no, they actually tried it. So Sean wrote back and said, no, it will not work because of things that they did. So they closed the issue. Didn't work either. So we're all back to square one. There is an issue that PowerMock once opened. They found another way for them. But here is now an issue that wants to have a feature to have a custom class loader for tests. So please push this. It's issue 201. But meanwhile, we are developers. If extensions are too late in the project, we can maybe write an engine, right? Engines are the new runners. So how would a roboelectric engine look like? Engine actually is not as complicated as you might think. An engine has two methods and two things it has to do. It has to discover your test and has to execute your test. Why do you need something like this? Think about the nested classes, right? So the nested tests, you need to discover those because a normal Junit4 wouldn't see those, right? That's what the engine does, discovery and execution. And then you have to announce this, which is the Java service loader method. So you just have one file where you announce yourself, and automatically it will work magically. That's all you need. So for the test case I wanted to build for this final test runner, I thought, actually, that's very easy because I want exactly to do the same thing as Jupyter, as Junit5. I can just copy the code over. So I could use either the class or I had to copy them over for visibility, but this was all the code that my engine had. Plus, I would use, I would change the class loader. So the context class loader, because I'm too early to change the class. And you know what? It worked. I could run a roboelectric class on Junit5. And then Jupyter engine ran and did the same thing and failed, of course. So Jupyter ran twice. My test engine and the original one. Which is not an issue, you can exclude it. Which brings you to new issues because, hey, but what if you have like roboelectric and normal Junit5 tests? Make sure that your engine can support both. So roboelectric as an engine, would it work? It would. I think so. But there's actually a lot more. roboelectric has all these annotations, right? To set up your manifest stuff and like this. You have to rewrite all of this. So there's a lot of things in the roboelectric test runner. But we're the community, maybe we can do it. So might be worth a try. What are actually engines? Spec, for example, and Kotlin tests, they wrote already engines. These are existing Junit5 engines. It makes a lot of sense for them to define their own, so that they're not bound to the Junit4 limitations. And actually extension, so two that might be related, Mockito extension is the Mockito version of the Mockito rule we had before that would just fill your admocks. So this is more what an extension would do, while engines are more the heavy things, right? So this will leave it like this. So instrumentation, yep. Espresso, probably. Roboelectric, no. So now you might ask, hey, Junit5, should I go? You definitely should. But there's no hurry. Junit4 is completely under maintenance. You have all the time in the world. I would say write new tests in Junit5. If the test is not roboelectric that you're touching, try moving it over to Junit5. Change just the imports. Be aware of the supported and the unsupported test rules. So if your test rules, just check. If they extend test watcher, check if this is really what you want. Start moving your rules to extension. Most of the time it's very easy and actually much more clear. And of course, try to remove some roboelectric because it's not good anyway. Here are some resources. I really like the last article on the first blog, which is about especially Kotlin and Junit5. And the last three about the history of JUnit. So if you want to see a 1-hour video of Kent Beck. It looks a bit of a weird video. It looks like an interrogation in a gray room. But he talks about how they built JUnit. And for example, fun fact, when they did this and gave him other high fives, right, every time they had a green test on that flight, they really annoyed the guy next to them. And they later found out that's a federal agent. So they were lucky that they didn't have any problems. So I made it in time. I'm really surprised. I hope you still got it. As I said, we are having front-end and back-end guys in Berlin. And we can either take questions now or later on beers at a party. I like talk about testing. Thank you.